So this is our 7th lesson from Unit 10, and today we're going to look at factoring by grouping, and also solving monomials as well by factoring too. So we had a little warm-up just to remind us of a few of the rules we've been using in the last few lessons. So a lot of people prefer to do this question like this. So two numbers at times to make 25 and subtract to make 0. So that should be 5 and 5, and with the signs being different, one's plus and one's minus, and you should just check that that works. Now, if you do the same idea with this, two numbers at times to make 25 and add to make 0, then you're going to find that that's pretty impossible. So that one doesn't factor, so we can just write prime for that one straight away. Now, you can do slide and glide on this question, give yourself x squared minus 20x plus 100, and then two numbers at times to make 100 and add to make 20, and get 10 and 10. But look from what we did last lesson as well. These are both perfect squares, so we might want to try first 2x and 5, 2x and 5. 2x times 2x is 4x squared, 5 times 5 is 25. Both signs are the same, they're both negative. And actually check, if we multiply this out, do we end up with what it says there? And yes, indeed we do for this one. Now, also, we don't want to do slide and glide for this question either, because otherwise 84 times 3 is going to give us a very large number, 252, and we're not going to be able to find two numbers at times to make 252 and subtract to make 9 easily. But there is a GCF on this question. So factor out the 3 first of all. And then actually this isn't a slide and glide question anyway, because this doesn't actually factor. So two numbers at times to make 28 and subtract to make 3 is going to be 7 and 4. And the biggest sign has to be positive, and we're done. Now, that's just a little reminder of some of the methods that we used, and our first thing that we looked at today was factoring monomials. Now, we've actually done factoring monomials before, but I'm going to do them set them equal to 0, which is something that we didn't do. Now, we looked at two different methods when we first did this. We looked for the GCF for this. Notice they both have an x here, and you take the one with the lowest power, so x to the 2 and x to the 1. Would just be x, and then we have to look what do we need to multiply this by to give us this expression. Now, when we set them equal to 0, this is something we didn't do with this. When we look at this, when does this equal 0, and when does this equal 0? Now, the first one's already done for us, 0. And when does x minus 15 equal 0? Then we can just add 15 to both sides, and we can get 15. Or if you want the shortcut for this, just look at the sign here and then do the opposite. So negative 15 becomes positive 15. When we have x or 2x or 3x, the answer is always going to be 0 for that question, because anything times 0 is always going to give us 0. So that's the solving part of this question. And we have two answers because look at the power in the question. That's something that we're going to use to help us figure out how many answers we actually have. Now, some people didn't like factoring that way, so I did show another method. You can break it down into product of primes, so x squared is x times x. 15 I could write as 3 times 5 as well, but I'm just looking to see what do I have in common. Well, they both have an x, and then look what's left over, the x minus 15. So it's the same answer, but just a different way of getting to that answer. And you use the one that you prefer. Now, second one, slightly bigger factors this time. 8 and 20 are both in the 4 times table. Notice I've got two x's again, so take the one with the lower power, x to the 2, x to the 1, so x. So your ECF is 4x. Then we've got to look, what do we times 4x by to get 8x squared? Well, 4 times 2 is 8, x times x is x squared. 4 times 5 is 20, and I already have the x, so I don't need anything else. Now, solving this equal to 0 again, what we're really saying is either the first one is 0, or the second one is 0. So 4 times the number is 0, that must be 0. And for this one, if we went ahead and solved this, we could add 5 to both sides, and then divide by 2. And actually it's the same thing we did in the previous question, we're just doing opposites here. So when this was negative 15, we said 15 was a solution. Same for this, so instead of doing negative 5, I got positive 5, instead of timesing by 2, divide by 2. So it's a much quicker way where you can just write down the solution straight away. Now, I've also shown you the other way again, just to remind you. So if you spotted that this does divide by 4, and you still need to be able to do that, then just go back to the question. So I said, what do I need to times to get 8? Well, 2 times 4 is 8. 2x is here because it's x squared. I know there's a 4 as a factor. 4 times 5 is 20, and I need my x on the end. And then just look what's the same here. So I can see both have a 4 and an x. But then what do I have left over? 2x. And what do I have left here? 5. So you still get the same factors, but just a different way of writing your answer. And at this stage we then practice from the worksheet that we had a few lessons ago. Now we also looked at factored by grouping. Not particularly one of my favourite methods, but there is a procedure that we have to follow for this. So this is going to be characterised by when we have 4 terms in our expression. And we're going to split the question in half and look at 2 terms at a time. And we're going to factor the first 2 terms, really using the method that we just saw in the previous section. We're then going to factor the second 2 terms, and then we're going to factor the whole expression based upon that. And when we do that, this should be a common factor in here, but also in here, as you'll see when we look at the questions. So, if that was my question, and notice there's no numbers on this, which also sometimes phases people. We're going to split the question down the middle here, look at these 2 terms. So notice these both have r as a factor, and then we've got y plus z left over, or y plus z. And then here, a is a common factor, and then we've got y plus z here. But notice I have the same factor here. This was a plus here, so I'm going to put the plus back. So what I can say is I've got r plus a times by y plus z. If you wanted to check with FOIL to see this works, r times y is ry.
Attention in the building, anyone?
And we'll continue. We just had a little interruption in the building there. So if I was to continue multiplying out here, r times r is ry, and then I just check the rest just to make sure this question does work. Now I revealed the second question at the same time, so split the question down the middle, look for a factor. Both of these have a, b minus 1, a times 1 is a, so be careful on that one. cb minus c, both of these have c as a factor, c times b is cb, and c times 1 is c. They both have a b minus 1, so that's one of my factors, and then what I have outside the parentheses is my other factor, so a plus c. Now I have a third question which I'm not particularly that pleased with, mainly because all the terms have a b, so I could have taken b as a factor for all of these, but if I follow the procedure I did, we'll split it into 2. Both the GCF of 2 here, but also b, so 2b is the factor, and then 2b minus a. If you distribute this, we should get this. Factor of b here as well, not surprisingly, and then if we distribute, we can see that works as well. Now for this one, they both have 2b minus a as a factor, so what do I have left? 2b plus b, so actually I can put 3b times by 2b minus a. Now I was disappointed with this question because I hadn't realised when I'd actually written the question that we could actually simplify at the start here. So 4b squared plus 2b squared is 6b squared. Negative 2ab, take away another ab, is negative 3ab. And then if I factor this, I can see 3 as a factor and so is b. Then I get left with the answer that I had here. Oops. And it's not going to let me scroll up any higher, I don't think. So I actually made a mistake when I wrote out my answer here, so we'll just ignore that part there. There we go. Alright, last example, or next to last example. This time I can split this in half here. 3b and negative 6b squared. So 3 and b are certainly a factor of both. 3b times 1 is 3b. 3b times 2b gives me 6b squared. Now for this one here, I also took the negative as a factor here. And the reason I took negative as a factor here is because I'm trying to get 1 minus 2b in the middle here so I can collect terms here. So I took negative 1 as a factor, so negative 1 times 1 gives me negative 1, and negative of negative 2b is positive 2b. 1 minus 2b is clearly one of my factors, and everything outside the parentheses is going to be my other factor, so 3b minus 1. And you could, once again, do FOIL on this just to check to make sure you have the right answer. Now, once you start to get the idea for these, it all seems very nice until you get to this question. So, split it down the middle. We've got dt plus s. And there is no GCF here. These are all different letters. And same for the other half as well. There is no GCF for this. So we have to switch the question around a little bit. We can use our commutative rule. So if I change the order around, if I move this term to here and move this term across, then notice now there is a GCF here of t, and there is a GCF here of s. So I'm allowed to do that using the commutative rule. And then if I try and work it out, then I got t times d minus 1 plus s times 1 minus d. And it looks like this doesn't work because these two are the same things. But notice what I have here. I got d over here and I got negative d over here. I got negative 1 and I got positive 1. So these are actually exact opposites of each other. So if I was to factor out negative 1 as well, then actually this would work perfectly. So s times negative d is negative sd, and s times 1 is the same as negative s times negative 1. But notice now I do actually have two factors that are the same, and therefore I can group them together just like I did before. So keep an eye out for questions where it doesn't look like you can factor by grouping, but you can rearrange the terms so you can actually get something that you can work out.